Hello guys, welcome back in another video. In this video or lecture we are going to study about earthquake and its effects. So let's start. Earthquake hazard zonation, risk evaluation and mitigation. The importance of seismological okay. Let me zoom it through. Okay, set my camera. Okay, the importance of seismological studies lies in the fact that information generated can be used to mitigate the earthquake hazards. Preparation of seismotectonics and seismic zonation maps. Just wait a minute. Should I keep it? Okay. The basic data required. The basic data required for the preparation of these maps are: number one, carefully compile earthquake cataloging, incorporating details about magnitude, location of epicenter, depth of focus, etc. Number two is delineation of seismic source zones from all possible sources like recurrence, relation, tectonic, geological consideration, etc. And the next one is the estimation of upper bound magnitude through statistical procedures, cumulative seismic energy release, active fault length, etc. And the number four one is attenuation of ground shaking for better results. And seismic microzonation is recommended for better results. These maps give an idea about the possibility of occurrence of earthquake in the region. Okay, and are very useful for evaluating the risk involvement before designing and constructing the heavy engineering structures like dams, bridges, flyovers, and large towers, etc. These are also useful for planning human settlements that would remain safe during the occurrence of an earthquake. And seismic risk evaluation is also possible from these maps. Indian Meteorological Department, National Geophysical Research Institute, Department of Science and Technology, Bhabha Atomic Research Center, and Regional Research Laboratory have established a large number of seismic monitoring networks in the country, including northeastern region. These stations are recorded useful seismic data, which enables to determine the location of epicenter. Useful seismic data which enables to determine the location of epicenter. Useful seismic data which enable to determine the location of epicenter, depth of hypocenter, energy within the focus, and orientation of the geological structures that has undergone deformation, and many other parameters of earthquake. These parameters are then listed. These parameters are then utilized for preparing seismotectonic and seismic zoning maps. The work in seismic zoning in India was started by Indian Standard Institute, now Bureau of Indian Standard, in the year 1916, and the first map was included in the code IS 1893 to 1962. A significant progress has been made since then, both in seismic zoning, and the instrumental monitoring of seismicity. However, many questions regarding the location and instrumental monitoring of seismicity. Of natural potential seismic zones faults still remain unsolved and need to be addressed to the new millennium. Okay. Okay, what are the okay? We will take a break for almost 20 seconds to start a new um, paragraph or a topic. In this previous topic, we studied that about the Indian state, how they will make their law according to the earthquakes or epicenters or hypocenters as well in Indian region, or maybe they almost make a law in 1893 to 1962. Okay. Okay, the next topic is what are the harmful effects of earthquake. We are also known that there are a lot of harmful effects of earthquakes, such as they produce a large number of disasters, like they destroy the homes, shelters, every business. They can destroy the economy of a country as well. They are well known of destructions as well. They can produce a huge amount of deaths as well. Um, we were seeing before in almost 2006 in Pakistan, the in almost KP region, the earthquake struck the KP region, and there are a lot of lives that we have lost. But don't worry. But don't. In the upcoming years, the Pakistan made their earthquake changes in his laws as well, and now there are seismic designs buildings in Pakistan as well. So let's start our the next topic. What are the harmful effects of earthquakes? Damage to human structures. Earthquake cause great damage to human structures such as buildings, roads, rails, factories, dams, bridges, etc., and thus cause heavy damage to human property. Landslides. The shocks produced by earthquake, particularly in hilly areas and mountains, which are tectonically sensitive, cause landslides and debris fall on human settlement and transport system on the lower slope segments, inflicting damage to them. So this is the second one, landslide. We will study. We have already studied about the damage to human structures, shelters. Okay. The next one is fire. The strong vibration caused by severe earthquakes strongly shake the buildings and thus causing severe fires in houses, mines, and factories because of overturning of cooking gas, contact of live electric wires, turning of blast furnaces, displacement of other fire related and electric appliances. Number 4 is flash floods. Storm Due to earthquake, flash floods will produce. The explanation we will study in this subtopic. Strong seismic wave cause damage to dams, thereby causing severe flash flood. Severe floods are also caused because of blocking of water flow of river due to rock blocks and debris produced by severe tremors in the hill slopes facing the river valleys. Sometimes the blockage is so severe that rivers change their main course. Number 5 is deformation of ground surface. Okay. Severe tremors and resultant vibration caused by earthquake results in the deformation of ground surface because of rise and subsidence of ground surface and faulting activity, formation of faults, and the tsunami. The sixth one is tsunami. The seismic wave caused by earthquake measuring more than 7 or Richter scale traveling through sea water generates high sea waves and cause great loss of life of body. Okay, these are the six effects of earthquake that we have studied. There are several type of volcanic eruptions due to earthquake as well. Some of them are written in this chapter. Okay, take a break of 30 seconds, then we will start. Okay. Okay. Several types of volcanic eruptions during which lava, tephra, ash, lapilli, volcanic bombs and blocks and assorted gases are expelled from a volcanic vents or fissure have been distinguished by volcanologists. They are often named after famous volcanoes where that type of behavior has been observed. Some volcanoes may exhibit only one characteristic type of eruption during a period of activity, while others may display an entire sequence of type all in one eruptic series. There are mainly three different types of eruptions. The most well observed are magmatic eruption, which involves decompression of gas within magma that propels it forward. Phreatomagmatic eruption are another type of volcanic eruption driven by the compression of gas within magma, the direct opposite of the process powering magmatic activity. The third eruptive type is the phreatic eruption, which is driven by the superheating of steam via contact with the magma. These eruptive type of often exhibit no magmatic reel, instead causing the granulation of existing rock. Okay, within these wide definitions that we have studied, almost three adaptive types are several subtypes. The weakest are Hawaiian and submarine, then Strombolian, followed by Volcanian and Sustanian. These are the sub types of the types that we have studied before. These are one of the weakest types, and the stronger types are as follows. The stronger eruptive types are Pelian eruption followed by Plinian eruptions. The strongest eruption are called ultra-Plinian. The strongest eruption are called ultra. Mm, okay, eruptions are defined by their mechanism and varying strength. An important measure of eruptive strength in volcanic explosivity index, an order of magnitude scale ranging from 0 to 8, that often correctly correlates to eruptive types. Harmful effects of volcanic eruptions. Volcanoes affect people in many ways. Some are good, some are not. Some of the bad ways are the houses, buildings, roads, and fields can get covered with ash. As long as you can get the ash off, especially if it is wet, your house may not collapse, but often the people leave because of the ash and are not around to continually clean off their roofs. If the ashfall is really heavy, it can make it impossible to breathe. They can okay Lava flows are almost always too slow to run over people, but they can certainly run over houses, roads, and any other structures that can cross their limits or that can that the lava can touch. The lava will burn it. Okay. The next one is okay. Okay. The next one is Proclaimed flows are the mixtures of hot gas and ash, and they are very quickly down the slopes of volcanoes. They are so hot and shocking that if you are caught in one, it will kill you. Definitely, it will kill you. They are also so fast, 100 to 200 kilometers per hour. They can okay that you cannot outrun them. If a volcano that is known for producing proclast flows is looking like it may erupt soon, the best thing is for you to leave before it does. Okay. Some of the good ways that volcanoes affect people, including producing spectacular scenery and producing very rich soil for farming. These are the good things. Okay, the next topic is gases. These gases are released from volcanoes. We will study in this lecture. Gases, water vapors, the most common gas released by volcanoes, causes few problems. Sulfur dioxide, carbon dioxide, and hydrogen are released in smaller amounts. Carbon monoxide, hydrogen sulfide, and hydrogen fluoride are released, but typically less than 1% by volume. Gases pose the greatest hazard close to the vent, where the concentration are greatest. Away from the vent, the gases quickly become diluted by air. For the most people, even a brief visit to our vent is not a health hazard. However, it can be dangerous for people with respiratory problems. For example, asthma. The continuous eruption at clears present some new problems. Long-term exposure to volcanic fumes may aggravate existing respiratory problems. It may also cause headaches and fatigue in regularly healthy pupils. The gases also limit visibility, especially on the leeward side of the island, where they become trapped by atmospheric conditions. Sources information volcanic and seismic hazard on the island of Hawaii by Christine Heliker in 1991, U.S. Geological Survey General Interest Publications. Okay. The next one is a deadly eruption. I think we will take a break of 30 seconds and then we will restart the deadly eruption. Okay. What are the deadly eruptions? The 1815 explosive eruption of Tambora volcano in Indonesia, and subsequent caldera collapse produced 9.5 cubic miles over 40 cubic kilometers of ash. The eruption killed excuse me the eruption killed 10,000 people and additional 80,000 people died from crop loss and famine. It is the huge amount of people died in that eruption. Okay, the next one is aircraft. How air, aircraft affected by the earthquake? They are in the air. They are not touched to the ground while flying. How they can be dangerous for aircraft? Can you imagine? Okay, I will tell to you. To protect mildly, ash is bad for jet aircraft engines. Apparently, the problem is much more severe for modern jet engines, which burn hotter than the older ones. Parts of these engines operate at temperatures that are high enough to melt ash that is ingested. Essentially, you end with tiny blobs of lava inside the engine. This is then forced back into other parts where the temperature are lower. Okay, let me zoom it. You can see it clearly. I think I zoom it too. Okay, I think okay. Okay, this is the force back into the earth parts, into the other parts where the temperature are lower and the stuff or solidifies. As you can imagine, this is pretty bad. One problem that I heard about is that pilots start losing power and apply the throttle, causing the engine to be even hotter and melt more ash. Added to this is the fact that ash is actually tiny particles of glass plus small minute shards, pretty abrasive stuff. You can imagine that dumping a whole bunch of abrasive powder into a jet engine is not good for the engine. This has been a pretty known scientific explanation of the problem. Okay, I just found an article that is describe the problem a little more technically. The ash erodes sharp blades in the compressor, reducing its efficiency. The ash melts in the combustion chamber to form a molten gas. The ash then solidifies on turbine blades, blocking airflow and causing the engine to stop. This comes from the FAA Aviation Safety Journal, Vol 2, number 3. Safe distance. Okay, we will take a break of 30 seconds, then we will resume it. You can also skip this 30 seconds as well if you want. Otherwise, you can whatever you want. Okay. let's start. The distance you have to evacuate depends entirely on what kind of eruption is going on. For example, Pinatubo, one of the larger recent eruption, sent pyroclastic flows at least 18 km down in flanks and pumics falls ever horror and heavy even beyond that. For example, pumice 7 centimeter across fell at Clark Air Base which is 25 km from the volcano. A centimeter forming won't necessarily kill you, but it does mean that there is a lot of them falling. And if you don't get out and continuously sweep off your roof, it may fall in and you will get squished. On the other hand, the current eruption at Drapua is relatively small. In effect, there were skies up on the slopes when the eruptions commenced, and even though there were only 1 or 2 kilometers from the vent, they managed to escape. The volcanologists routinely go up on the higher slopes of Rafua during these ongoing eruptions to calculate ash and take photographs to analysis or to get results or future predictions as well. Okay, so you see, you need to know something about what you think the volcano is going to be before you decide how far to run away. I guess if you have no idea of what the volcano is planning and have no idea of what it has done in the past, you might want to be at least 25 to 30 kilometers away. Um, you must, must away 25 to 30 kilometers. Okay, make sure you have a good escape route to get even farther away if necessary, and by all means, stay out of low lying areas because the magma will does not stop cities and towns. The next topic is cities and town. I think we don't need a break of 30 seconds or 1 minute. We will take a break after this topic. The effect an eruption will have on a nearby city could vary from none at all to catastrophic. For example, atmospheric condition. Excuse me. For example, atmospheric conditions might carry ash away from the city, or topography might direct lahars and pyroclastic flows to unpopulated areas. In contrast, under certain atmospheric eruption and or topographic conditions, lahars, pyroclastic flows, and or ash fall could enter the city, causing death and destruction. The scenario brings up several interesting problems. How do you evacuate a large population if there is a little warning before the eruption? I have a question for you in this paragraph. This scenario brings up several interesting problems. How do you evacuate a large population if there is little warning before the eruption? Where do these people go? If an eruption is highly likely yet hasn't happened, yet how long can people be kept away from their homes and businesses? These are the questions that been asked by the book or author, And the below are, I think the answers are below on this topic. I should point out that in most volcanic crises, geologists advise local civil defense authorities. These civil defense authorities decide what to do concerning evacuation, etc. Okay, the lavashi has two. Okay, I think we should take a break of 30 seconds. Okay. The IAVCEI has a program to promote research on decade volcanoes. Decade volcanoes are likely to erupt in their near future and are near large population centers. Mount Rainier in Washington and Mauna Loa in Hawaii are two decade volcanoes in the US. Other decade volcanoes including Santa Maria, Stromboli, Pinatuba and Unzen. What happens to the towns around a volcano when it erupts depends on many things. It depends on the size and type of eruption and size and location of the town. A few examples might help. The 1984 eruption of Mauna Loa in Hawaii sent lava towards Helopard. The eruption stopped before the flows reached town. The 1970 eruption of Haimai in eruption in island buried much of the nearby town of Mai under lava and cinder. The 1960 eruption of Kailua in Hawaii buried all of the nearby town of Kapuho under lava and cinder. In 1980, ash from Mount St. Helens fell on many towns in Washington and Oregon. The 1902 eruption of Mount Pelee on the island of Martinique destroyed the town of Saint Perry with pyroclastic flows in 1985. The town of Armiro was partially buried by lahars generated on ruins. For more example, see Decker and Decker in 1989. How are the earthquakes and volcanoes distributed? We will see in the next video. Thank you. Okay. How are the earthquakes and volcanoes distributed? Volcanoes distributed all over the world in different countries and continents, but are now not found in every country. Found mostly on the coastlines, especially on tectonic plate boundaries, volcanic prone areas, and the ring of fire around the Pacific plate. Across the North and South Atlantic Ocean, there are still anomalies, hotspots, earthquakes. Millions of teeny earthquakes happen every day, but we only manage to notice the bigger major ones. Okay, found on mainland and coastline, especially tectonic plate boundaries, earthquake-prone areas around Pacific Ocean along the Indo-Australian plate boundary, eastern side of erosion plate, western side of North America plate, and the volcanoes and earthquakes are both found plates boundaries. However, there is difference between the two since volcanics are never found on conservative and divergent boundaries because there is no change in crust to allow more magma molten rock to be made. This is the picture. You can see there are different plate. North American plate, okay, John the Fuca plate, Pacific plate, Erosion plate, Arabian plate, Indian plate, Australian plate, Philippine plate, Pacific plate, African plate, South America plate, Nazia plate, Cosco plate, Caribbean plate, Scotia plate, and Antarctica plate. You can see the top ones are the North America plate on the top left, and the top right are the Eurasian plate. The fully left side is the Pacific plate, and the fully right side is on Pacific plate and Philippine plates. You can see there are two plates in the same region, Pacific plate and the Philippine plates. You can see, okay. And the bottom plate is Antarctica plate. In the middle there are Australian plate, African plate, Scotian plate, South American plate, and Asian plate, Cosco plate, Caribbean, and the middle ones or the center ones are Arabian plates, Indian plates. These are the plates situated in all over the world. So this is, I think, enough for this lecture. Okay, and let me open the next lecture, then I will resume the video. I have opened the next lecture. In this lecture, this is also the disaster management policies. In this lecture, we are going to study about objective methodology and scopes, about disaster management policies. So let's start. Number 4 is objective methodology and scope. The objective of this review is to demonstrate whether on the basis of literature available, local institutions play a role in natural DRM at the household and at several institutional levels, and if they do, to understand how this occurs and what are the strengths and weaknesses of the actors and stakeholders. And stakeholders involved in decreasing DRM capacity at several levels. Achieving this objective implied are as follows. These are some points, 7 to 8 points. Okay, investigating how local institutions have dealt with actual disaster, event, or mitigation. Mitigated in their impact on their member constituencies, analyzing how population groups in disaster prone areas have usually dealt with the area, are dealing with the disaster risks, rehabilitation and development through local institutions, assessing the implication of mitigating disaster risk for all local institutions and their effectiveness at doing so, as well the impact of the wider institution environment, identifying the lessons learned from local institutions involvement in DRM, focusing on potential improvement in terms of their role and organizational development needs, providing elements of a pro-poor DRM strategy that highlights and strengthens the role played by local institutions at that level. Local actors better equipped to deal with the disaster management cycle. And the last one is and elaborating how policy and operational support at subnational, national, and international levels. You can see there are sub-sport national, subnational, national, and international level can better sustain local institutions in TRM and local and longer term development. These are 7 to 8 points that we have discussed about the policies that we have should made. Okay, this literature review focuses less on the myriad of informal local institutions that are also standard local practices, such as those derived such as those derived from custom, like e.g. certain context specific agriculture traditions within a given farming system that have evolved and become adopted over many generations to suit local exposure to potential natural disasters. In looking at existing local institutions, emphasis was placed on those with relatively more potential to bridge the mitigation development continuum, and microfinance institution MFIs were singled out as promise to that effect. With respect to natural disaster, the present paper concentrations on rapid onset phenomena such as floods, hurricanes, snowstorms, and earthquakes and their associated effects, landslides, heavy rain, etc., rather than a slow onset phenomena such as droughts or some other often protracted events such as rodents, predators and pests, or human and animal epidemics, which is another reason for more examples coming from Asia and Latin America rather than from all over the world. Rather than Africa. Neither include are volcanic eruptions because of their more localized effects, nor bush and grassland fires and other such events. These are mostly man-made and thus not purely natural, rather than predominantly meteorological and seismic in origin. The secondary data collected comes from all developing regions and sources. The way to access the material has been mostly through the internet, where a range of studies, projects, documents, strategy briefs, newsletter, etc. has been downloaded in either English, French, Spanish, Portuguese, and German. Other information was provided by colleagues working in or with projects that contain DRM components. Number 5 is certain overview of local institution response to natural disaster. Certain local institution responses have taken place within the project framework that sought to coordinate local government and civil society contribution with those of TRM experts. The proyecto fortalecimiento de esfuerzo local MID. I think this is the next level language. For example, implementing from 1997 to 1999 in Costa Rica, Guatemala, Honduras, Nicaragua, and Panama. Wait a second. Okay, Panama was a pilot initiative aimed at responding to communities' interest to participate in jointly analyzing the cause of natural hazard, uh, the risk and the vulnerability involved, and the actions that can be taken to mitigate negative disaster impacts. Diagram 1, a local risk management system in Guatemala source family GTC 2002. Okay, this is the diagram. The process to accomplish a local risk management system: actors, population at risk plus awareness rising plus introduction to the notion of risk plus activities to manage and reduce risk. This is the process to accomplish a local risk management system. Civil society, what are the main roles of civil society? Individual players, locally organized players, local institutions, local government, sectoral institutions, and with local representation. Local history of visible risk, community experience training, and the next one is risk hazard, vulnerability and training. The next one is prevention, mitigation, preparedness, PMP, prevention, mitigation, and preparedness. Okay, we will take a break, then we will resume it. From there, we will left it. Okay, we have studied the process to accomplish a local risk management system. PMP, prevention, mitigation, and preparedness. We have already studied these three: prevention, mitigation, and preparedness. In our previous lectures, we have also studied risk, hazards, vulnerabilities, and trainings. We will also do. Okay. The okay. Our next topic is okay. Our next topic is horizontal and vertical institutional interaction at local, meso, and macro levels. There are three levels: local, meso, and macro levels. Start from the start. Disaster risk mitigation in a cyclical, dynamic process that requires continuous adjustments, decision making, and interaction at different yet interrelated levels and among a variety of institutions and actors, including individuals, households, communities, non governmental organizations, market institutions, and government. World Bank 2001, Meliti 1999. Local institutions may thus appear on the scene at various stages. Regrettably, not many case studies exist on the role they play or may play during the different phases or throughout the DRM cycle. Following the latest earthquake in Gujarat, India, this decentralized and well coordinated nature of its relief distribution network enables SIVA to provide, educate, and timely post disaster assistance. A three-tier mechanism with teams working from the village through the district to the state level was adopted by the institution to carry out its earthquake response and assistance program. Okay. At the community and district levels, teams ensured that the distribution of relief material was adequate and timely. At the state level, which is smaller countries could be said to correspond to the national level. Okay, I will see it. Or you can also edit the table as well. If you insert a row, column, insert a left row, left column, you can also, for example, you want to insert an above, you can see this whole document has been copied and pasted in the above of this table. Okay, if you want to add a picture or any other image that we need in our document or in an assignment, you can click on this device and get a proper picture that you have been saved in your computer. You can insert that picture in your document or in your assignments, or you can also copy that image from mobile devices, stock images, and you can also insert the picture from online pictures, or you can copy that image from Control C or paste that picture by Control V, or just right click on the document and you can see there is the paste option. Just paste it. Okay, we talked about different type of insert images, tables. Now we can add charts as well. Click on the charts or whatever chart you need, for example line chart, column chart, pie chart, bar chart. You can also radar. If you want to draw radar, you can write from this histogram. You can, for example, I need a histogram, click OK. You can see this is the histogram, or if I want to edit the histogram, I can also edit. Okay, this is the line, you can see. Okay, this is the layout option. Okay, and okay, or we can add, or for example, I need to draw something with my hand or with my cursor, I can write it. For example, I need an arrow, I can draw an arrow. Or I need to write something with hand, I can easily write it. Or if I want to highlight some things, I can easily highlight that type of things as well by pressing it and drag, press and drag. Or if I want to remove that thing, you just need to click on that thing. You can clearly see it has been removed. Okay. Oh, you can add watermark as well. You can, for example, do not copy. You can see on my screen or on your screen that a single page write do not copy or do not copy. Okay. You can change the fonts from here as well. Okay, let's come to the layout. This layout is mostly used where you need to write a proper document or a proper assignment, so you can easily use these layouts in your documents, assignments and other type of things. In this first of all, there is a margin. You can draw margins as well. There are orientation, whether you need portrait or a different. This is the size. We can already set our size by A4 page by clicking on the columns. If I want 3, you can see the MS Word created 3 columns by default. If I need 1 column, you can see this is the 1 column. You can these things by your own, or you can check this by your own as well, because these are not much used in the simple documents or in simple assignments as well. This is the most important thing, references. When you are doing final year project, these are one of the most important things in the documents. For example, you will take different you will take different topics from different authors, or you can take different ideas from different authors. You can reference that file in your documents as well. This is the most important things, and this is the most important thing. You can use references. You can also use plugins of different softwares to use these references as well. These references are very helpful in research papers or in article writings. Mostly good authors will use these references in their documents, articles or in reference papers as well. This is the mailing, not muchly used in simple tutorial of MS Word. This is the review section. We less use this section because these are mostly review the document, mostly used when we want to review our documents. Okay, this is the view. If we create a new window, you can click on this. If you want to arrange all the documents you can click on this, all the papers, sorry, document not all the papers, you can click on this. If you want to split a paper, you can click on this as well. This is the you can zoom. For example, I need 75%, click OK. You can see this will zoom 75%. If I want to show, for example, first page here and second page here, click on this. You can see if I want to see only one page at a time, I will click on this and close, zoom it. You can also see there is only one page is showing. If I will click on this, you can see this there are two pages in a single show. Okay, let's come from home. Okay, there are as we also see, there are different things that we have discussed before. We can also, for example, if I want to, oh yes, these are here. If we want to for example, where is the word I will write? For example, I need to paragraph, all the words are capital. If I need all the words are capital, I will go there and click capitalize each word. Wait a second, go there. Oh yes, you can see these will change their sizes as capital with. Okay, if I want to click capitalize each word and then click uppercase, you can see all the words will capital. Okay, if I write, for example, small words, or then click capitalize each word, you can see the first word or the first letter of a word will